Okay, so we were talking about concentration, and I have my two glasses here. This one is the dark red. You can see that this is very concentrated. It's a dark red. This one is the light red. I did not put as much food coloring in, so this is not as concentrated. So you can see the difference in color. But we can't just say this one's more concentrated and this one's less concentrated. We have to say how concentrated is it. So we need some kind of measurement that's going to tell us that, because we can't do calculations based on approximates. And you know that, I know that, I mean, we know that. So we do have a measurement that we use, and it's called molarity. Molarity. And it has something to do with moles because it's molarity. Molarity is moles of a solute divided by liters of solution. The solute is the stuff being dissolved, and the solution is the liquid that is dissolving it. So, in this case, this is the food coloring, and this is the water. Molarity is measured in moles per liters, or moles per liter, but we don't write it out like that. What we use is a capital M to represent molarity. That's how we write it out. So we're going to do, we're going to make an imaginary solution, I know, and we're going to figure out the molarity of it. So what we have here is, let's say we have 20 grams of NaCl. We measured out 20 grams of NaCl, and we want to dissolve that 0.50 liters of solution. What would be the molarity of our solution? How concentrated would it be? So we're going to do moles per liter. Now we have liters, we don't have moles, but we can do a very quick calculation to convert that to moles. So we would go 20 grams of NaCl, and we would use our gram to mole ratio. So on the periodic table, 1 mole of NaCl would be 58.44 grams of NaCl. Remember, I just looked those up on the periodic table by adding 1 sodium and 1 chlorine together. Anyhow, you divide that out, 20 divided by 58.44, and we would get 0.34 moles of NaCl. Okay, so this solution that we're making, what is the molarity of it? All we do is take the moles and divide them by the liters. So we're going to have molarity equaling 0.34 moles divided by 0.50 liters, and this is going to work itself out to be 0.68 moles per liter, but instead of that, we're going to use that capital M. Oops, went off the page. All right, so this solution would be 0.68 molar. So we say the molarity, we say 0.68 molar, and molar is representing molarity. Capital M, and that represents moles per liter. So if you ever see a solution in a chemistry lab, it will always be marked with some kind of molarity, and it'll have some kind of measurement there because it's telling you the concentration of that. And next week I'll show you how to use that concentration to measure things. It's how you measure. Anyhow, answer the questions, and I'll get back to you next week.